I will now move on to the next question. 4 conducting plates, each of area A, are placed equidistant from each other. The inner plates are connected electrically to point A and the outer plates are electrically connected to the point B as shown. The effective capacitance of the system is option A, epsilon 0 A divided by D, option B, 2 epsilon 0 A divided by D, option 3, 3 epsilon 0 A divided by D, option 4, 4 epsilon 0 A divided by D. To calculate the effective capacitance, I want to draw an equivalent circuit to this arrangement. I request you to please note the way in which we are drawing the equivalent circuit. Let me start from the point A. This is the point A. You can notice that A is connected both to the plate 2 as well as to the plate 3. Therefore, A is connected both to the plate 2 as well as to the plate 3. They are separated by the plates 1 and 4. They are separated by the plates 1 and 4. The plates 1 and 4 themselves are connected to the point B. The plates 1 and 4 are connected to the point B. Can you not easily notice that it consists of 2 capacitors which are connected in parallel? If C is the capacity of each condenser, then the equivalent capacity will be equal to 2C. Since A is the area, D is the plate separation, each capacity is epsilon 0 A divided by D. Therefore, effective capacity is 2 epsilon 0 A divided by D. Hence, option B is the correct answer. There is one very powerful method of finding the equivalent resistance or equivalent capacity, and that method is called successive reduction method, where the circuit is analyzed part by part and the equivalent resistance or capacitance is found. To illustrate this process, let me take this question. The effective capacitance between the points P and Q of the arrangement shown in the figure is option A, half microfarad, option B, 1 microfarad, option C, 2 microfarad, option 4, 1.33 microfarad. I want you to concentrate over the circuit. Let me consider P and another point as R over here. Then you can notice, let me now consider only the circuit between P and R. Coming to this one, if you consider this is P. P is connected to the capacity over here. This is one capacity. That capacity is connected to the next capacity. It is connected to the next capacity, where the next capacity is connected to the point R as shown in the figure. Similarly, P is connected to one more capacity on the other side. That is connected to another capacity over here. This is another capacity. Then that is again connected to the point R. Note that between this point and this point, there is another capacity, that is 5 microfarad. This is 5 microfarad, while the other capacities are 2 microfarad each as shown in the figure. A little consideration will show you that 2 by 2 is equal to 1, 2 by 2 is equal to 1. Therefore, it forms balanced Wheatstone's network. Please note that even though Wheatstone's network is considered to be only for the resistances, it can equally be applied to capacitance. Otherwise, there is another way to look at it. Can you notice that if you draw a dotted line along this, the circuit on one side is mirror image of the circuit on the other side. Therefore, as I told in some question earlier, you can notice that it is having a vertical symmetry along the dotted line. Capacitor 5 microfarad is connected along the line of symmetry, therefore it can be removed from the circuit. Then 2 and 2 are in series, 1, another 2 and 2 are in series, 1, 1 and 1 are in parallel, 2 microfarad. Therefore, equivalent capacity between P and R is going to be equal to 2 microfarad. Next, can you notice that between R and Q, there are two capacitors, each of the magnitude equal to 1 microfarad, but connected parallel to one another. Since they are connected parallel to one another, again the equivalent capacity between R and Q is also going to be equal to 2 microfarad. Then, can you notice that if you consider this as one part, this as another part, 2 microfarad and 2 microfarad are connected in series. Hence, equivalent capacity is 1 microfarad. Therefore, option number B, that is 1 microfarad, is the correct answer. Now, I am taking another question on successive reduction method. In working this question and many other questions further, one point that you should remember is that if any two points are connected by a simple connecting wire, they may be treated as equivalent to one another. If you have this basic concept in your mind, believe me, this question becomes really very simple. Let me read the question. In the accompanying circuit, if the point C is connected to the point A and the point D is connected to the point B, the effective capacitance between the points A and B is. Look here, he says that the point A is connected to the point C, while the point B is connected to the point D. Please note that A is connected to C by a simple connecting wire, D is connected to B again by a simple connecting wire. Therefore, D and B may be taken as same and A and C also may be taken as same. Then the given circuit can be written in the form of an equivalent circuit as. I request you to note how I am drawing the equivalent circuit. A is connected to the first plate of this capacitor. A is connected to the first plate of this capacitor. Second is connected to D. Note, second is connected to D, but D is as good as B. Therefore, it is connected to the point B and this point is A, and this is going to be equal to 20 microfarad. Similarly, A and C are identical. So, A is connected to first plate, second plate is connected to B. Again, A is connected to the first plate and the second plate is connected to B. As you can see, note that the capacity is again 20 microfarad. 20 microfarad. This also is 20 microfarad. Now let us see. I request you to please note it. A is connected to the first plate of this, second plate is connected to another condenser, another plate of the condenser is connected to B. Therefore, you can notice that A is connected to the first plate, second plate is connected to another condenser, second plate is connected to another condenser, another plate is connected to B, another plate is connected to B. Same thing, A and C are equivalent. It is connected to the first plate and the second plate is connected to the first plate of the next condenser and the other plate is connected to B, other plate is connected to B. Each of these are 20 microfarad each. You can notice that these are 20 microfarad each. I request you to please note the middle part of the circuit. 20 and 20 are connected in series, equivalent is 10. Another 20 and 20 are connected in series, equivalent is 10. This 10 and this 10 are connected in parallel. It makes capacity as 20 microfarad. If you now consider the circuit between A and B, 20 microfarad, another 20 microfarad, another 20 microfarad are connected in parallel. Therefore, equivalent capacity is 20 plus 20, that is 60 microfarad. Therefore, option B is the correct answer.